So next example in 6.3. So we are given these equations. So notice here we are given the function in terms of y. So we have a function of y, and the revolution is about the x-axis. So we are fine, because remember, when we revolve about the x-axis, we have to integrate with respect to y. So I set the two functions equal to each other. This one is 0, so negative y square plus 6y is equal to 0. Simplified, factored, and we found that these are the limits on y, 0 to 6. So I'm trying to graph the function now. It's a parabola, and because y square has a negative sign, so it is open left. And at 3, when y is equal to 3, the value for x is also coming out to be 3. So this will be a parabola, something like this. So we have this, and then x is equal to 0 means the y-axis. So this side. So the region is this one. And we have rotated about the x-axis, so kind of this is what we get. So our typical cylinder will be so that now let us write our integral. So v is equal to integral from 0 to 6 2 pi, and remember the radius is y, that will just remain y, times the height. So remember the height of the cylinder is the function, so negative y square plus 6y dy. So I get negative y cube plus 6y square over 2 dy, which gives me 2 pi negative y cube plus 3y squared dy. I integrate, I end up getting negative y to the 4 over 4 plus 3y cube over 3. So I just get y cube, and limits from 0 to 6, 2 pi negative 6 raised to the power 4 divided by 4 plus 6 cube, and then minus the zeros, equal to 2 pi. Now 6 to the 4 is 1296. Let me put this first. This will be 2 pi times 1296, sorry, we have first the 6 cube, which is 216, minus 1296 over 4, which gives me 2 pi 216 minus 324. So 2 pi times 108, which is 216 pi. Okay, looking at the next example. So again you have to use the cylindrical shell method. Find the volume of the solid obtained by revolving the region bounded by y is equal to x squared plus 1 and y is equal to negative x plus 1 and x is equal to 1 about the y-axis. Okay, let's try. First let us try to either set them equal to each other. Okay. Okay, let me first draw the y is equal to x squared plus 1 will be a parabola like this. Then y is equal to negative x plus 1 will be the line going like that. Then we have x is equal to 1. So here this parabola should be a little, because at 1 it's 1, now it will be 1 again here. And so the line x is equal to, this is the region that we are talking about. So the limits on x are from 0 to 1 and we need the limits on x. So our v is going to be integral from 0 to 1 2 pi r. So this is revolved about the y-axis. This is the shape we are getting. So 2 pi times x times, now the height of the cylinder will be this much. So it's the difference of these two functions. So this one is x squared plus 1 and that one is negative x plus 1. So I will write it in terms of the, so x squared plus 1 minus negative x plus 1 dx. Okay, let us first clean inside. X squared plus 1 plus x minus 1 dx. So 1 and 1 cancel out, so we are left with x squared plus x. And then we have an x out here, so multiply it in integrate. Minus 0, and then we are getting 2 pi into 7 over 12 which makes it 7 pi over 6. So that is the volume. Okay, the last example is different from any of the ones that we just did. So this time we are revolving it about another line, not one of the axes, but a line parallel to the x-axis. So y is equal to negative. So we graph the function first. Okay, so it is saying that the y is equal to 9 minus x. That is the main our function. And so let's say this is 9. And let's say this is 9 over here. So the graph is going to look like this. And then y is equal to 0 is the x-axis, and x is equal to 0 is the y-axis. So this is our region, and we are going to, now this is not to scale, but at y is equal to negative 1 is this line, so the graph is being revolved about this line. So it will be, this is 1, this distance between here is 1, and I have to go one more to draw my piece. So this is our solid. So how will a typical cylinder look like in here? So the radius is now, remember radius we always measure it from the axis of rotation. So it will be measured from this to this. So this one is x, and then we have plus 1. So the radius is 1 plus x or x plus 1, and the, wait a minute, y plus 1, right? Because we are revolving about the axis parallel to x-axis. So it will be y plus 1 or 1 plus y, and then the height will be, so this will be the height, is the x value, so we have to figure that out from this equation. So x is equal to 9 minus y, so height will be 9 minus y. So our volume will be, and the limits you can see are from 0 to 9. You can also set these two equal. 9 minus x equal to 0 gives you x is equal to 9, y is equal to, x is equal to 9, which means y is equal to 9, and then we have y is equal to 0. So from 0 to 9, 2 pi 1 plus y, and then 9 minus y dy. So you have to be careful when you have these lines which are not on the axis but parallel to the axis. So you have to add or subtract whatever the situation is, that much value. So we distribute get 9 plus 8y minus y squared dy. So 2 pi times 9y plus 8y square. over 2, which means 4y square minus y to the 3 over 3, 1 to 0 to 9, 2 pi 9 into 9 plus 4 into 9 squared minus 1/3 into 9 cubed, and then minus 0. 2 pi times 9 into 9 is 81 plus 81 into 4 is 324 minus, so this will be 81 into 9, 729, 2 pi 81 plus 324 is 405, and we have to subtract 729 from there. No, so 729 divided by 3. We have to divide this by 3 as well. So which will give us 729 divided by 3 will be 243. So we have 405 minus 243. So 2 pi times 162. So 324 pi. That will be our answer. So this is how we do these problems with the cylindrical shell.